Hello, my name is Maarten Meijer. I'm a student at the University of Twente, and today I will take you with me on a journey into explainability of AI systems. This is our world. Take a look around you. AI is no longer a futuristic concept. It's here, embedded in our daily lives. From robots to self-driving cars, and from chatbots to AI-assisted diagnoses in hospitals. Our world is becoming increasingly dependent on artificial intelligence. But there's a problem. While we see the outcomes, we rarely understand the process. The systems we rely on are often black boxes, complex, opaque, and unexplainable. We trust them, but we don't always know why they do what they do. This is where explainable AI comes in. It's not just about making AI smarter, it's about making it transparent, trustworthy, and accountable. Because only when we can see through the black box can we truly harness the power of AI responsibly. So, why do we need explainable AI? The first and foremost reason is to justify outcomes of an important system. Nowadays, AI decisions can have great impact, giving us need for legal and ethical accountability on our decisions. Secondly, explainable AI allows us to control and correct the behavior of models. With this, we can ensure the AI model actually focuses on the right information and gives its decisions for the right reasons. Thirdly, experts can spot when a model is making poor assumptions. Only if we can see how it's reasoning can we collaborate with AI to improve it. And lastly, explainable AI allows us to see the inner workings of models that are better at tasks than humans are, making us discover new knowledge. But let's bring this closer to home first. Say you're using an AI model to detect anomalies in a network. It flags a connection as malicious. But why did it do this? Was it the packet size, the frequency of requests? Maybe it was a rare protocol combination? If the model is a black box, we're simply left guessing. But if we instead take an AI model with explainability, you can see which features influence the decision and decide whether it's a real threat or a false alarm. So far, we've talked about why explainability matters, so also let's take a look at when and what we explain. There are two key dimensions to this, and the first is when we explain. We have two options. The first is to explain a model intrinsically. They're built to be transparent from the start. The other option is to explain a model post hoc, meaning after it's been trained. Often this is because they're too complex to understand directly, like a neural network. Then the second dimension is what we explain. We again have two options. The first is to only explain a single decision of a model. We call this a local explanation. And the other option is to completely explain the model entirely, and we call this a global explanation. Let me give you some examples to make this more concrete. The local and intrinsic explanation is, for example, something like a rule-based system. Here, a network packet was flagged, and it was flagged because it matched the virus template, so we know exactly what's going on for this decision. But if the model is way more complex, like a neural network, we can also do something else, like LIME. This is where we fit a simple linear model onto the space around a single decision. In this case, it is about a fish, and we have a model saying whether it's edible or poisonous. And because we use LIME, we can now see which features influence the decision the most. And in this case, it was the smell of the fish. There's also a global intrinsic explanation, meaning we have a model built to be transparent from the start, and we can see all of it, like a decision tree. Here we can analyze the full model and see what it's doing and why. But if we again have a more complex network, we can also do something called SHAP. Here we use Shapley values, added stolen from game theory in mathematics, and we can use it to see which features contributed most to some other outcomes. In this case, the price of houses. We can see that if you have higher average room counts, in general, the price of the house will be higher as well. Let's also take a quick look at how we see inside the black box. There are many options to this that I didn't show you, but there are some examples on the screen. For example, we have heat maps to see which areas of an image a model focuses on. We can have prototypes which show typical examples of some of the classes. We can also completely synthesize an image from only the weights of the model itself, or we can use text-based explanations. There really are so many options. We have started with a world powered by AI, but clouded by uncertainty, a black box at the center of it all. The future of AI isn't just about better models, it's about better understanding. Let's not settle for black boxes. Let's build systems we can look into, learn from, and trust. You don't need to be a data scientist to demand transparency. Thank you.